distributed between those two values right there. And they want the probability that the value will be between these two numbers. Okay, so the basically with a uniform, the height is whatever the difference of these two are, but it's 1 over that.
Okay.
That gives you the height of this rectangle, and the rectangle goes from 67.9 to 91.9. But in this case, we only want kind of this region in here.
Okay.
So the height is 1 over 91.9 minus 67.9, and you multiply that by the width of this rectangle, which is 89 minus 71.2. You're finding, but essentially find the area of this inner one there. So
Okay.
I'm going to grab my calculator. I would suggest you also do the calculations just in case there's any discrepancies. We can, avoid, any unnecessary errors. But
Okay, let me see. I think I got it. I got 0.74167.
like that.
Okay, so that one's just basically.
Actually, yeah. I'm still typing mine in, but
Oh, sorry.
If you feel good with that, yeah, I got the same there. So, is that okay?
Yeah.
Are there any other questions on the uniform distribution that we could do now, rather than kind of jumping back and forth the whole time? Which is fine if we do. It just will be
No, I don't
discontinuous.
think so. I think that was the only one.
All right, so I see 14 I see is next, I think.
Yeah.
All right. Are you using the program R in this class?
What is that?
Well, I see this R here. That's why I keep asking.
I don't know. It's just we're on Canvas and that's what it's on.
Okay. R is statistical software made by IBM, and some instructors use it. There's other ones like SPSS and things like that. Okay. So this one is a random sample n equals 41, and they have an X bar of 1191 and a standard deviation of 64. What's the probability that mu is greater than 1184.6? So the only thing that I have to ask here, because I don't know the context, is does this one is not necessarily a t-test or a z-test. It depends on a few things that might be going on in your class. If I didn't know anything, I would tell you it's a t-test, because you would use a t-test for basically any n unless sigma is known, and sigma is not known. This is the sample standard deviation. So I'm gonna suggest we do a t-test here.
So basically a t-test is done when there's an n? No,
when there's an s. Or when n is small. And so this case, n is relatively small. So some instructors do this. They say if n is greater than or equal to 30, you can use a z-test. That's wrong, but some instructors do that. Like, hopefully the answer that we do for this is here and not the other one. Okay. Like basically I'm trying to say, like, I want to tell you the right answer, but I don't know if it will be.
Okay.
So the t here is it's x 1191 minus 1184.6 over s divided by the square root of 41. So you get some t value here, okay? And you probably know this from class. The t distribution looks something like this. So we're gonna get a t value, and we need the area over here. The degrees of freedom is n minus 1, which is 41 minus 1.
Okay. And then
we need to look that up. So all of this can be done in software. Like if you have a calculator, I could show you how to do it, or I can just pull up my own.
Are you saying like we'll look at the value on the t table then?
It depends on what you're looking at. So no, the way these are written, you would want to actually use software to calculate it. The fact there's given 5 choices here.
Yeah.
So that would like what I'm suggesting is there's calculator, there's Excel, there is, any number of software packages like StatCrunch, online calculators, and so on. Like
Okay.
what do you want us to do, or do you just want the answer?
Probably
Like,
calculator, because it's like, this is our review for a test and we can't use Excel. It's just like pen, paper, and calculator.
okay, so I've got that TI-83 that I can show you how to work through this with.
Okay.
Yours will be slightly different. You'll have to, if you've got yours handy, you'll want to talk me through the entries, but let me get that up. All right, so I'm going to new share. I'm going to new share calculator. Okay, so if you go to second distribution, you want the TCDF. So let me know when you get there. Yours probably, though, will have a screen that says a bunch of things. And that's what I have to look up because I don't.
Okay.
But
So you said TCDF, right?
yes.
Okay. And then it says lower, upper, DF, and paste.
Okay, so lower. Is there not some stuff above it for like X bar or mu or S?
You want me to show you?
Let me. You could send a picture if you want. I'm gonna just look it up on the web here also.
Okay.
84 TCDF. Well, that's not right. Sorry, maybe I grabbed the wrong thing. Let me go back to stat test. Oh yeah, sorry. We want a t-test. Stats. Sorry, I took you to the wrong place. I apologize.
Okay, so
It's under stat. You go over to tests and t-test.
Okay.
Yeah, and the other thing does work, but it's for something different. So your mu in this problem is 1184.6.
Okay.
Your X bar is 1191. Your S is 64. Your N is 41.
I don't. Oh, never mind. Sorry, I was doing it wrong. My fault.
And then you want right tail, and we can talk about that in a moment.
Okay.
So the choice here to calculate or draw, if your instructor says to draw it like a graph, then choose draw. But if you just need the number, like in this problem,
Yeah.
just calculate it.
Okay.
Your p-value is 0.26281. I bet I chose the wrong direction because I didn't read the question carefully enough. It says more than. Let me go back and look. There's an error in this question because it says, what is the probability that the sample mean will be more than?
Okay.
Unless I switch these. Did I? Sorry, I have the mu and the S. I'm sorry, I have the mu and the X bar switched. I misread the question.
So you're good.
And we'll just go back.
Oh, okay.
Stat. Second quit. Stat. It's probably more valuable anyway to see how to do this.
Yeah. Okay.
1191. All right, and then let's try this. There we go. That's a more reasonable answer. 0.73. So your answer is not here.
Yeah.
Which means that this is probably your instructor saying this is a z-test because its sample is more than 30. The thing that is unclear to me, see how it just says standard deviation? They don't say like a known population standard deviation.
Yeah.
So the change here is to go stat
And then you just click on like Z test.
and do a Z-test. And
Okay.
you have that choice between data and stats. We're doing stats. It does try to copy over some of your data. See how it moved like those values already in there. So let's try this one. 0.73. So like if I had to put an answer here, like I would guess I would go 0.7389, but I would for sure ask the instructor. I would say, hey,
Maybe she was using the Z table to calculate it.
Yeah, is it possible that she used the Z table?
yes. Yes.
Okay.
There's no way
Probably.
to know for sure.
Okay.
And that's kind of the best we can do for that. So let me just really quickly update the numbers in this other thing because I really messed it up bad.
Okay.
And then I'll go back and grab the next one.
You're good.
Okay, so let me grab the next question that you want to look at. 18, is that okay? Or maybe
yeah.
that other email.
Yeah, that's 18.
Okay. All right, so we're gonna use the calculator again for this one, but let me just snip it in and then just run through like a couple of things to get it. But you're gonna go back to the stat thing again.
Okay.
All right, let me just go back to that. So it says a sample n equals 74 observations is taken, population proportions. This is your P.
Okay.
P is 0.24. The probability that the sample proportion is less than 0.32. Okay, so we want the probability that P is less than 0.32. And this way, this is written poorly again, but we're going to go back to the calculator. And this time you're going to go stat tests, and then it's a one prop Z test, one proportion Z test.
Okay.
And we care about what we care about is whether the the P0 is 0.24. I don't know how this helps to say it. P0 is 0.24. Your N is 74.
Okay.
And your X is not given in this problem. Your X comes from the fact that there are 0.32 times 74. And you can actually do that calculation in here.
Okay.
Like if you do that, it'll do it when you hit the down arrow.
Okay.
And we want less than, so that's it's important to change that. This time I'm going to draw just to see what it looks like. Maybe I think it also gives the p-value there. Okay, didn't like that. Let's go back. Quit. Stat. So I believe the calculator doesn't like that X is not an integer, which will potentially impact your answer space. This is yet like another one of those things like, I don't know what to tell you. I'm really sorry.
That's okay.
Instructors do weird things.
Yeah.
So you can see here, none of these matched up with what you showed me. And I don't know what to tell you.
Okay. That's fine.
Is to use a different tool, but like you said, you're going to have this on your test.
Yeah.
So if the answers here are really important, I would use an online calculator or an alternative thing. And I'm happy to find one or do it on my own to get you the right answer if that's what you're looking for. But
no, you're okay. We can just move on and then I can ask her about that because I'll just see how she wants it done and just so we can cover everything.
Sounds good. Okay. So it's 31 looks like it's next.
30, yeah, 31.
Okay.
Because I was kind of confused and I wanted to ask how to know when you reject the null hypothesis versus fail to reject null hypothesis.
Okay, let's talk about that. So I've snipped this question in. Hopefully you're seeing the other screen I use here. So you need a p-value.
Okay.
Okay, and there's really two possibilities. If p-value is greater than alpha, okay, alpha is given in the problem, maybe.
Okay.
It is not given. Okay, that's not good. So the alpha level is usually like, there it is. I'm sorry, I didn't see it. There it is, 0.01. Okay. So if you get a p-value greater than alpha, you reject the null hypothesis. There's no exceptions to that.
Okay.
I'm sorry. P-value, this is if the p-value is less than alpha, you reject the null hypothesis. Like this would go on a reference sheet. This is always true. If p-value is greater than alpha, you fail to reject.
Okay.
Okay. Now, when I look at this, when I look at the questions that's asked here, they're not asking for the p-value, but that is what you want to use to make this decision.
Okay.
So in terms of like how to do this, you want to first find the t-value,
Okay.
which we're going to use the calculator for. We're going to enter in this into the t-test.
Okay. So
Okay.
Stat t-test. And then for like the mu,
Mu is
equal to
88.
Okay.
So you're,
X bar is 89.3.
yep.
S is 8.3. And then N is 42.
And your direction comes from the alternative hypothesis here. So it's this greater than.
Okay. And then just calculate.
Yeah, so give me the t-value that it calculates.
So the t-value is 1.015.
Okay, so notice that gets you down to two possibilities. What is the p-value?
The p-value is 0.158.
So notice this p-value is greater than alpha. It's greater than 0.01.
Okay.
And that's how you decide between the two.
So
you fail to reject. Sorry, go ahead.
Greater than, it's failed to reject. Okay.
Yes.
And then the option is going to be failed to reject the hypothesis, and his statistic it equals 1.0151.
Yes.
Okay, that makes sense.
Yeah, it looks like the third one is the right answer if you're.
Okay.
And so sometimes you really only use the p-value to make this decision. You can use the t to compare to a critical t-value, but the p-value is way more similar across all the tests that you do. You can use that always.
Okay. So, okay, I think I get that now.
So 33
So I was
is
just
going to be
confused how you like fail, how you pick that, but that makes sense now.
yes, and this is always true. There's no exceptions to what I wrote here. Like it always works out this way.
Okay, that's perfect.
Okay, so this is another question like the previous one. N is 39. X bar is 8. I'm sorry, mu is 8. The sample X bar is 8.2 and S is 0.6. And this time your alpha is 0.01 and they tell you it's a t-test.
Okay, so then
so you want to find t.
The exact thing.
Yes, you want to get the t, and then we're going to use the p-value to decide whether it's big.
Okay, so we have 8, 8.2. And then the sign of the direction of the sign, it is used. So on like the t-test, do I pick like greater than or less than? Okay. can't do that, right? I feel like I did something. Oh, we're looking for the p-value, duh. Still think I'm I am just not getting any of these options. Wait, what the hell did I do? Oh, I typed in the wrong thing. Okay. That would make sense. This is easy too.
All right. You should have gotten T equals 2.087.
No, I did not.
Okay, let's go back and look at it one more time here. Let's try to show you without jumping in here. So your tests.
Oh my gosh, I have a little typo. Sorry. Okay.
Yeah, so when you calculate it, do you get 2.0817 and P of 0.044?
I had 34 typed in instead of 39. So yeah. I got the same thing.
Okay, so now let me go back to the other screen, and you'll notice if you're looking at the question on your screen that you'll see that it could be the first two options. Okay, this
Okay.
p-value is greater than 0.01. Okay, since it's greater than, you fail to reject.
Okay, so
do you see how answer A is 2.0817, same with answer B?
mhm.
This is 33, sorry. The choice then is either reject or fail to reject, and it's based on the p-value. The p-value is greater than 0.01, so you fail to reject.
Okay, so it's just a matter. I just need to remember if it's greater than, and you fail to reject less than.
Yes, this right here. Remember, I'll send you the notes at the end. Like, this is the most
Yeah.
important thing. Like this, if
Okay.
you got to have that down.
Yeah.
Instructor should have been screaming that every class. Most
Yeah.
important
I
thing.
mean, she was.
All right. It looks like you sent a second email. Let's.
Yeah, I had one more. I don't remember. I think I went out of order a little bit, but
32 here. Okay. This question here is asking you to infer what is H1, or what is the alternative. So if the null isn't equal to the alternative, so this is the null, this is the alternative is a not equal to.
okay.
If the null is a greater than or equal to, the alternative is a less than. If it's a less than or equal to, it's a greater than. This you also want to remind yourself of somehow before any formal test.
Yeah.
So the reason that's important is that tells you whether it's a one-tail or a two-tail test. So because it's an equal to, it's a two-tailed test, which means this z of 1.5 also corresponds to a z of minus 1.5, but only because it's a two-tailed test.
Okay, and it's a two-tailed test because it's an equal sign, you said?
Yes.
So if it wasn't, then that would be.
If it was a greater than or equal to, the left, this is I should have wrote that. This is two-tail, this is left, and this is right tail.
Okay. Okay.
And this isn't meant to confuse you, but there are instructors who incorrectly go and make this the null and then use one of these others as the alternative, but hopefully that's not happening here. So in terms of like what you need to do to answer this question, if you understand this picture, then you have options. You can either go and figure out how much area is in this left tail and then double it to get the total, or figure out how much is in the right tail and double it to get the total, or find the area between them and subtract from one. Do any of those sound better than another?
I would say probably just finding like the left tail and then doubling it.
Okay, so I'm going to go back to the calculator and show you how you might do this. You
Is
can
there,
use,
if we're getting a T-chart on the table, will that help me with this question?
you'd want the Z and you just go and look up minus 1.5 and then double that number.
Okay, so we'll take. Let's see, so I take the Z chart for 1.5 and then you said subtract that from 1.
No. You want to get this area. I'm sorry, I'm not showing that anymore. Sorry. Let me go back. You want the area in the left tail. So whatever area this is, and then you want to double it. So go look at your chart and I'll tell you what I think the answer is, and hopefully they're similar.
Okay, and I'm looking at a Z chart, right?
Yeah, yes.
Okay, so
So I get 0.0668.
and then doubled it and I got 0.1336.
That sounds right. Yes.
Okay, so that, and could I do the same thing? No, so you have to find the left tail.
Yeah, because if you find and that's why this question is written this way, because if you go to 1.5, it gives you left tail and it gives you all the area you don't want. You just want the two extreme areas.
Okay. Okay. Okay, let me see.
They give you the mean.
I'm gonna
distribution.
send one more question over. If
Sure.
that's okay.
Yep, of course. I'm just going to mute myself for 30 seconds, but I'll look for the email and then unmute myself.
Okay, you're good. I have a quick question about, I just sent over that email.
Okay.
But I have a question about when we're in like the t-test, typing it in on the calculator,
Yes.
you're picking like the direction that the mu goes, if it's like greater than, less than, or not equal to, how do you know which to pick?
It always comes from whatever is in the alternative hypothesis. So let me go back and show you just a couple of questions we did
Okay,
to answer that. Do you see how this was right here? Was it greater than?
yeah,
That's the direction because it's the alternative one.
okay, so you pick that.
The first one we did was, it says more than. That's how you know that's a greater than.
Okay,
So that it always comes from the alternative hypothesis. This tells you the direction of the test.
okay,
All right, so I got an email here. Take a look at another question here. Okay, so number 7 and
yeah,
okay. All right. And just for future reference, in case you care, I don't mind if you share the booking with someone else. If they want to jump in on their own screen, it's totally up to you. Just let me know so that because if I see someone coming into the room that I don't know, I won't admit them, but I'm happy if it helps you to share it with someone, or, however you want to do that. But
okay, thank you.
the question here says, okay, the daily dinner bills are normally distributed, so they got a mean X bar of 33.9 and a sigma of 7.6.
Okay.
And they want the middle 80%. So they want 0.8 here. And they want you to find these two numbers right here. So how much is in each tail is a question you should ask yourself. The whole thing is 1. So there's 0.1 in this tail and then 0.1 in that tail.
Okay.
And there's two approaches here. We can either do it by hand or we can use a calculator. Which would you prefer?
By hand.
By hand. All right. So the Z equals X bar minus mu over sigma. So this is something you saw before.
Yeah.
Okay. So we need the Z value right there. So
Okay.
you can get that from your table. You can, but it's an inverse norm. Like it's the area is 0.1. So which Z value corresponds to that?
0.1 is 0.5398.
Let me just confirm here. I got minus 1.282.
Oh crap! Sorry, I was looking at
Is
the.
that okay?
Yeah.
Okay, and that's
Yeah.
really important because that helps you to figure out what's going on here. So they sometimes in books they actually solve this for the X bar. And it's not necessarily X bar, it could just be X. So when you solve for X equals Z sigma plus mu.
Okay.
So you take that Z value just found, you multiply it by the standard deviation, which is 7.6, and you add 33.9 to it. And that'll give you the left bound.
Okay.
Okay. And then to do the right one, you do the same calculation, but with the Z. And because of symmetry, you know, it's just the positive of the other. So let me do that calculation and see what I come up with here.
I got 24.168.
Okay, so that looks like it's there. It looks like it is there. Like once you get the lower bound, probably the upper bound is right. You could always check it just to see.
Okay. So
but-
then. Okay.
So that looks good. I could just confirm that. And then for the upper bound, looks like it's 43.64.
Yeah. And okay.
So it comes from this formula right here that I'm boxing in. I mean, you've seen this
Okay.
before, but
Yeah.
sometimes it's solved for the X value that you care about,
Okay.
what you're asking for. And then you know, just again, be careful, like 0.1, like you want to ask yourself, am I given the area to find the Z, or am I given Z to find the area?
Okay.
And those are the two scenarios that come up, you know, in this part of the course. Because
Okay.
in this problem, you're given the area to find the Z value.
Okay, that makes sense.
All right. Is there anything else I can help with for today?
I think that's it.
Great. Well, thank you again for scheduling. I'll send you the notes here shortly and I'll see you next time.
Thank you.
Have a great day. Bye now.
You too. Bye.